zero exponent. Thus, for any variable number a, where a is not equal to 0, you'll have a raised to 0 is equal to 1. So let's try to solve some problems with zero exponent. Examples. Example number 1. 12x raised to 0. In this problem, make sure to identify the base of our zero exponent. So let's separate to see what is the base of our 0. It means 12 times x raised to 0. So here, x is only the base of our zero exponent. So it means we can change this whole expression to 1. This will give us equals 12 times 1 equals 12 times 1 is 12. So this is your answer for example number 1. Next, look at number 2. Although number 1 and number 2 seems similar, but as you can see, the base here is 12x, since you can see a parenthesis on our 12x. So this is equal to 1. So I hope you see the difference between 1 and 2. Next, number 3. So again, number 3 is combination of 1 and 2. So to solve for this one, look at number 3 equals x raised to 0. So let's solve here using PEMDAS. Let's solve first inside the parentheses. So x raised to 0 is equal to 1 plus 3. So just copy that 1 first. And then this whole factor raised to 0 means this whole expression or this whole factor is equal to 1. So you can change that to 1. Again, look at this carefully. Since x plus 3 is the base of our 0, we can transform this one or get the equivalent of this one, which is 1. Then let's simplify. 1 plus 3 will give us 4 times 1, which is equal to 4 times 1 is 4. Next, number 4. Again, we have here some combination of zero exponent. So 2 times a raised to 0. This will give you, again, 2 is not a base of our zero exponent. So we can retain 2 here. And then a is the base of 0. So we can change this to 1. Again, a raised to 0 is our 1. Plus, look again, the 2a here is the base of our zero exponent. So it means this whole expression is equal to 1 plus 28. And then, let's simplify. PEMDAS 2 times 1 will give you 2 plus 1 plus 28. Again, always to use PEMDAS, consider solving parentheses and then exponent and then multiply or divide, and lastly, you can add or subtract. So this time, let's add for the last step. 2 plus 1 is 3. Since we cannot add it with 28, we just copy 28. 2 plus 1 equals 3 plus 28. Then we can stop here. Last example, we have here 4m. And then this whole expression n minus p is raised to 0. So it means that is equivalent to 1. All over 4. And then here m is the only base of our 0. So that will be changed to 1. Equals. Let's simplify. Of course, as you can see, we could have here 4m over 4. And then we can simplify 4 over 4, which will give us 1. So this is 1m. Or of course, you need to neglect writing 1 here. So you can just have here m. So this is how to solve zero exponent.